Alright, in this video, let's continue working on the Freeplay screen, and let's begin putting together some implementation details. So starting up here at the top, we have our process show method. All we're going to do inside our process show is swap our map set over to the game maps. So what we'll do is we'll look into our input class, and we'll call upon change map set, and there we can pass in config.gamemaps. Alright, that is simple enough, and we can move on to the reset method. Inside of reset, we need to get our song set up. So we'll begin by saying that our song field is going to be equal to a new instance of song record. So we have our new specialized recording song set up and ready to go. Now there are a few things we need to do to this song instance to get it ready for play. We're going to begin by setting the tempo. So I'll grab song.bpm, and initially the tempo is going to be set to our configurable parameter, which is config.default recording tempo. Once we get the tempo set, we'll also apply some lead-in beats in a manner similar to the game screen itself. We'll give ourselves a full measure's worth of time that will pass before we begin playing notes. So we'll grab song.leadInBeats, and we'll set that to be equal to song.beats per measure. Alright, one last thing to do to the song itself is we'll make sure we do a call to song.reset, just to make sure that anything that needs to be taken into account is applied. Things such as the lead-in beats getting applied to our cursor value. Alright, one last thing we need to do inside of reset is make sure that we set our game's tempo appropriately for this song. So we'll make a call out to global state.setTempo, and we'll pass in the current BPM, which is found in song.bpm, and we will pass in the resolution of our song as song.ticks per beat, and that will give us the appropriate subdivisions. With that, that's really all the code that needs to go into reset. So from here, we can move on to some event handlers, which actually means we're going to do a little bit more work inside of reset. Just like we did in the game screen, as we were setting up the song, we also applied some event handlers to let us gain access to things like beats and notes being hit. So we're going to do exactly that here. We'll take our song, and we will look at its hit event. So we'll look into note hit, and we'll set that to a new delegate, and then a new event handler called song_note_hit. We'll turn around and do the same thing for a beat handler. So we have song.beat. We'll set that to be plus equals, tab out twice, and that will give us a song beat handler. Alright, inside of these handlers, let's first address beat. All we need to do here is make sure we fire off a metronome sound, though we are still going to consider the metronome active setting in our config file. So before we fire off any kind of metronome sound, we look into config, and we check the metronome active field. If that field is true, then we will continue playing. So we'll grab our global state in order to access Sound Engine. We'll tell Sound Engine to play a specific sound, and we'll drop in the metronome sound index. So again, we need to look into config, then we have our metronome sound index, which we can feed to the Sound Engine, and that takes care of our metronome. Alright, next up is note hit, and all we're going to do inside of note hit is to make sure that we send out the sound of the drum being played, because that's what we'll do inside of record mode, is in addition to seeing the notes go up on screen, it would make sense to hear the drums that you're playing. So we'll grab global state, Sound Engine, tell it to play, and we can pass in the track of the note that was just hit. So we'll grab note.track, and that takes care of our note hit. Now we can move down to update, and update is very simple. All we're going to do is take our song and call its tick method, just to make sure that time continues to advance. Alright, this leads us to our draw method. The first thing we'll do inside of draw is make sure we call upon the active renderer to draw our song. So we'll look into the renderer class, and inside of that we'll look at the active renderer and tell it to draw. We need to pass in a sprite batch, so we'll get that from our own parameter, and then we will pass in our song field as the song to be drawn. Now one last thing we'd like to do on this screen is draw the current tempo, and in order to do that we're going to need the same code that's currently in the game screen. So I'm actually going to jump over here to game, bring up screen game, because we can steal the code that we've already written in order to handle BPM text, and we can simply drop that into our screen Freeplay, and that'll save us a little bit of time, because again we're doing the exact same thing, only here we're not looking at a song's array, we're looking at a single song field, so I'll simply pull out the song's sub-zero part. And that should have our draw method all set up. Alright, that takes care of all of our methods except for input pressed. So let's move up to input pressed now and put together some code to look for note presses. The very first thing we'll do, since we'll be doing a little bit of work with our named input coming in from the input data, let's actually store that in a local variable for convenience sake. So we'll make a named inputs variable called named input, and that will be equal to input data dot named input. Now we can begin our first check. We can say if input data, or excuse me, named input. So if the named input is equal to named inputs
dot note.
There we go. Named input is equal to named inputs dot note. Then we are looking at a note press, and we need to turn around and pass this information on to the song. Now, since we do have a lead-in span of time applied, we want to make sure that no one is able to hit notes until the song is supposed to begin. So we'll do a check and make sure that our cursor is equal to or greater than 0 before we allow anything. So what we'll do is we'll do a check. We'll actually look for the opposite. We'll look for song.cursor, and if song.cursor is less than 0, then we're not yet going to allow any notes to be hit. Instead, we'll play the click sound. So we'll reach into global state, and we will grab our sound engine, tell it to play, and pass in config.click sound index. So basically we get our note mispress sound if the user presses notes too early. Now if the song cursor is equal to or greater than 0, then we'll allow notes to be pressed. So we'll call song.pressNote, and we'll pass in the current track, which is held in input data.data. That'll take care of getting the note press passed on to the song screen. And at this point, if everything is working for us, we should be able to jump in and test some things out. So let's run the game. Let's jump down to Freeplay mode and see if everything is bound up properly. If we hit select on Freeplay, Freeplay screen does not exist.
Well, yeah, that'll do it.
And that's probably due to the screen registration. Of course, we need to get the screen associated with the name back in our game class. So down here in game, let's scroll all the way back up to our load content section, and let's register a screen.
Well, here's your problem.
So here inside of our screens, we'll name the screen Freeplay, and we'll make sure we make a new instance of screen Freeplay. Now with that, our main menu should still be looking at Freeplay. Let's jump into the game, go down to Freeplay, and very nice. You'll notice as soon as the game loads up for play, we get a call to update, and the game crashes out on our song being null. Now why would song be null when we've clearly stated that in reset our song should get instantiated? I mean, we're doing it right there.
Right.
The problem is, does anyone ever call reset?
Exactly. Reset's not being called yet.
So we need to go back to our menus, all the way back to the main menu, screen main, and look for what's happening when we call Freeplay. Here we're pushing the screen Freeplay, and we never call reset. So we're going to turn around and look at screen.ActiveScreen and make sure that reset gets called in order to get the screen all ready to go. So now if we jump in and invoke Freeplay screen, now we've got a metronome sounding, and if we were to hit notes, then we get the notes played along with the metronome.
Nice.
So we can So with
Best drum beat ever.
So with the combination of my drumming skills and this wireless keyboard, we can get some very not so great sounding drum patterns entered into the game. But we do in fact have all the sounds being played as well as all of the notes appearing. So we have at this point a functioning Freeplay game screen. Now let's test a few other things. Currently we have no way of adjusting the tempo, and it would be nice to allow the user to change the tempo so they could set up the kind of rhythm that they want.
Mm-hmm.
In order to do that, we'll jump back to the Freeplay screen up here at the top under Input Pressed, and we'll allow input from the up and down directions. So we'll put in an else if, and we'll say else if named input is equal to named inputs dot up. If we press the up button, then we'll, let's say, increment our tempo by 10. We'll grab our song, set its BPM, and increment it by 10. Then we'll turn around and we need to set the actual tempo of the game to reflect this new tempo setting in our song. So we'll make a call to globalstate.setTempo, where we'll pass in song.bpm and the current song.ticks per beat. Then we'll do the exact same thing for the down direction. As a matter of fact, I will grab the entire else if statement, drop it in place, this time looking for named inputs.down, and we will decrement our tempo, and then rerun the set tempo line. So if we run the game now, everything should be working to allow us to change tempo, but we'll run into another interesting problem. So we'll jump into Freeplay. There we have our metronome.
Are you going to do like crazy tempo?
We can speed things up. So very good. Now we have a BPM of 200. Or we could slow things way down. There's 60.
Mm-hmm.
And here's where the problem comes in.
Uh-oh.
If we start to set really low tempos, the entire screen starts to get a bit jittery.
Mm-hmm.
Meaning we're getting so low with our updates that our update and draw intervals end up, or rather our update interval, or tick interval, there we go, is less or lower than our draw updates,
Gotcha.
and far lower than 60 frames a second. So we get an easy to see, a very perceptible jitter in place. And we have the opposite problem too. If we were to speed up, I'm not going to do it on camera, but we could speed up the game to an unlimited tempo.
Sure.
And so we do want to make sure that we cap things out. So what we're going to do is we'll apply some limits to our song's tempo. And we'll do this from within the base song class. What we'll do is we'll go all the way up to the original field, and we'll change this field into a property. And that way we'll be able to better control the value as it gets set. The first thing we'll do is we'll change the name of the current field to lowercase bpm, since we're still going to use a field to store the data. Now you notice I renamed it simply by retyping its name. I didn't use refactoring on this one, and we immediately get a ton of errors as everything else looking for capital BPM no longer can find such a definition. Now we're going to redefine capital BPM as the property instead. This way it's kind of like we're throwing the property there in between the field and everyone trying to gain access to the field. So we'll make a public integer property, which will be called capital BPM, and we'll drop down and put together the braces for this property. Now for the get accessor, we're simply going to return the field's value. So we'll do a return this.bpm. Now for the set accessor, this is where we'll be able to gain control over the range that our BPM is allowed to reach. So let's begin by first setting it to the incoming value, and then we'll do a series of range checks. So to begin with, we'll go ahead and take our internal field, and we'll set that to be equal to the incoming value for the property. Now at this point, the tempo could be an improper value, something like a very slow or very fast value. So let's do a check and make sure that our tempo can never drop below 40 beats per minute. We'll do that using the math.max call. So we'll say this.bpm is equal to math.max, where we'll pass in this.bpm for value 1 and 40 for value 2. So what this is saying is BPM will then be equal to whichever is more, our current BPM or 40, which means if we set a valid BPM of 100, obviously that will remain. If we try to set a BPM of 10, we'll jump up to 40. Now we need to do the same kind of check, but as an upper bound. So we'll say this.bpm is equal to math.min.
It's funny how that sounds like it'd be exactly backwards.
Right, but because you're taking the other side of it, it's kind of like checking the sides of the screen. So once again, we'll pass in this.bpm as value 1, and then we'll specify our max tempo as value 2. I'll drop in a value of, in this case, we'll do, I don't know, 240. That should be plenty. Of course, depending on the music that you need to have the song or game represent, we could change that to whatever we need. I don't know, for the time being, let's do 340. Give ourselves more headroom. I was just trying to go through, like, you know, certain techno songs that are
sure
crazy fast.
I don't know why anybody would want to play live drums to techno. That just sounds more irritating and painful than it. I mean, I like techno. I just wouldn't want to actually play drums for it.
But again, since at this point we haven't actually composed all the music for the game, we do have to leave this kind of open. But the idea is that here we can enforce a tempo limit. And again, math.min is just saying take whichever of these two numbers is smaller. So if our BPM is 100, well, 100 is less than 340, so 100 stays. If our BPM is 500, for who knows what reason, we'll instead take 340 as the lower number and store that instead. All right, with these values, let's jump into the game and see what this sounds like. If we begin lowering the tempo, we hit 40 and can't drop below.
Very
so
nice.
now we remain with a smooth progression for our staff. And again, on the other side, we know that it's going to be capping at 340, so I won't jump in and test and stress our poor sound recording system. We're trying to record that many hits.
Right.
All
That takes care of input. I'm sorry, no, that takes care of your beats per minute, your tempo. So now what do you need to do?
There's a few more inputs that we'd like to handle. One is we'd like to give the ability to reset the whole staff to the beginning. In case you're playing along and you decide that you don't like how this beat is going, you want to begin from the beginning with a brand new rhythm, we'll let the game's reset button clear out all the notes and reset the song.
Okay.
So here inside of screen Freeplay, let's add a little bit more of input checking. We'll do another else if, and we'll look for named input to be equal to named inputs.reset. So if we find a reset press, all we'll do is clear out all the notes off of the current song, song.notes.reset, or excuse me, clear, to remove them all from the list. Then we'll turn around and reset the overall song, so song.reset. That way we get our cursor set back to the beginning with the lead-in time and everything else that comes along with reset. Alright, let's go ahead and jump in and test this.
Okay.
So inside of our game, bring up Freeplay. We have to wait till all of our time gets onto the song itself. Now we can drop in notes, decide that we don't like them. We should have spacebar currently bound to reset. So if we hit reset, now we see there goes the hit line again.
Nice.
So every time we hit the spacebar, we get everything reset.
Which, with our keyboard layout, you'd want to be really careful about that. It seems like it'd be real easy to reset your song.
Exactly. We're still taking the keyboard as being purely a development interface.
Exactly.
Because if you were really hitting keys, you wouldn't want the X key, which is right next to the spacebar, to accidentally reset your entire song.
You just perfectly recreated Tom Sawyer, including all solos and everything, and right toward the end of it, you tap spacebar. No!
So, yes, possibly not the best input scheme for a real game. But, alright, moving on, there's two more things we want to be able to do. At the moment, if you're inside of the Freeplay mode, you cannot hit escape to jump out of it. Freeplay mode never ends because we're never going to hit the end of the song because we're creating the song, and select does nothing. So that means unless you can get to the window to close it, there's no way to exit the game.
Gotcha.
So let's put in some input handling for back and for select. So I'll drop in an additional else if statement looking for named input to be equal to named inputs.back. And if we get the back button pressed, we'll simply pop the current screen and jump back to the main menu. So we'll call screen.popScreen. And then we can drop in one more else if. I'll copy and paste the last one that we just wrote and look for named inputs.set. select. So if we hit select, for example, the enter button on the keyboard, let's bring up the pause menu. Let's allow pausing in Freeplay just like we did in the game screen. In order to allow pausing, all we need to do is to push the pause screen, and then pause is otherwise set up to handle everything it needs. So we'll take screen, and we will push a screen onto the stack, and the screen we're going to push is called pause. Alright, let's try this out. First, jump into Freeplay and check the back button, which is escape on the keyboard, and we jump back to the main menu.
Okay.
So now let's jump into Freeplay again, maybe hit a few notes,
Nice.
and then hit select, and we're presented with the pause screen. So we're free to continue entering notes if we like, so we can even see the notes that we just hit, continue to scroll off the screen, or we can decide that at this point we're done with Freeplay mode altogether, and hit quit, which will pop both the pause screen and the Freeplay screen, dropping us back at the main screen.
Okay. So that seems to be working. Right now, we don't have the ability to save out that song yet, right?
That's right. We don't yet have the ability to find the song itself. Now, what's funny is we do have song saving capability. We wrote song saving earlier and used our procedural generator and our beat generator.
We just have to tap into it now.
Right. Well, now we just need to put the systems together. So that's coming up shortly, but we need to address it.
Okay.
But at this point, we have our specialized recording song, fully functional, and we have a Freeplay mode, which can now be used from the main menu, and everything's linked up, including the pause menu.
Very nice.
So with that, that's going to wrap up this video.